Good morning. My name is Ekwasin. So today I will present the PBL power electronic. So first is the elaborate of the working principle of a single phase square wave inverter. So a wave inverter is a type of inverter that convert DC voltage into a AC. The working principle of it is based on the switching of a DC voltage across the road while using a switching device such as MOSFET and IGBT. So the inverter consists of a DC source, a full bridge inverter, and a load. The DC source provides a constant voltage to the inverter, and the full bridge inverter consists of four switching devices and four diodes. The switching devices are controlled by a pulse width modulation or called as PWM signal generated by the microcontroller. So when the PWM signal is high, the switching device turn on and the DC voltage is applied across the road, and signal is low, the switching device is turned off and there's no voltage across the road. The switching frequency of a PWM signal is determined by the frequency of a AC output. The output waveform of a single phase square wave inverter is a series of square wave pulse with a fixed amplitude and frequency. The waveform contains odd harmonic, which can be used to cause distortion in the output waveform. The total harmonic distortion (TDH) of an output waveform is measured by the distortion caused by the harmonic. So, in conclusion, the working principle of a single-phase square wave inverter involves the switching of DC voltage across the road while using a full bridge inverter and a PWM signal. So next will be the difference between the SPWM inverter and SHE modulation inverter, and which one is better. So SPWM is a short form of a sinusoidal pulse wave modulator inverter, and SHE is a short form of a specific harmonic elimination modulator inverter. So let's talk about SPWM inverter first. SPWM is a technique that used to generate the output waveform that closely resemble a sine wave. So it can be achieved by varying the width of the pulse in the PWM signal according to the amplitude of a sine wave. SPWM technique used to push the harmonic to a higher frequency, make it easier to filter out the unwanted harmonic. So the output and the current spectrum of a SPWM inverter show that the first consideration harmonic is at a high frequency, and it is a technique that widely used and well established due to its simplification and efficiency in producing a sine wave. So next will be SHE modulation inverter. So SHE modulation inverter is a technique that used to aim to eliminate the specific harmonic in the PWM inverter by determining a set of switching angle. So by selecting a switching angle, certain harmonic can be eliminated, which can provide a cleaner output waveform with reducing the distortion. The SHE modulation technique requires more complex calculation and control algorithm to determine the switching angle. So the practical result of the SHE modulation inverter show it can produce a relative low TDH compared to SPWM inverter, and it is useful in application where specific harmonic need to be eliminated for improved performance and or certain standard. So in terms of which one is better, it depends on the specific requirement and application. Both SPWM and SHE modulator inverter can produce the output waveform with a low TDH. SPWM is more commonly used in various applications. It offers a good balance between the simplification and the performance. And SHE modulation provide more control on the elimination of specific harmonic, make it more suitable with the specific requirement. Yeah. So next will be the suggestion of how to improve the SPWM inverter. There are four ways. So the first is increasing the switching frequency. By increasing the switching frequency of the PWM signal, we can reduce the size and number of the output filter component required. This can lead to more compact and efficient inverter design. So next will be the implement carrier-based SPWM. Instead of using a fixed carrier frequency, we can use a carrier-based SPWM technique, where the carrier frequency varies with the amplitude of the preferred sine wave. This can help to improve the performance of a harmonic wave and reduce the distortion. So next will be optimize the control of algorithmic. So by control the algorithmic of a SPWM inverter, we can ensure the accuracy and the precise control of the switching device. It can help to achieve more synchronization between the reference sine wave and the PWM signal. So lastly, we'll be using a high quality component. So by selecting a high quality switching device such as MOSFET or IGBT with a low switching loss, and this can help to reduce the power loss and improve the efficiency of the inverter. So that's all for my part.